All right. So just really quick to remind you what we did here. Okay. So with Hess's law, we have this final equation that we want to obtain from these reactions. So it will undergo these reactions and it'll end up with this. Okay. And so we are given the delta H of reactions for each of these individually. All right. And we're able to manipulate those so that it will match this. So for example, here we needed C2H2 as a product of this reaction. Down here, it's a reactant. Okay, so we switched this. We rewrote this so that we had the C2H2 over here as the product. Okay. When we did that, we had to change the sign of delta H. We changed the sign of delta H from a negative to a positive. Okay? All right, the other thing we did was we had to take this top reaction and we had to multiply it by 2 because we needed 2 carbons. So to get those 2 carbons, we multiplied this top reaction by 2. Okay? And we were able to obtain twice the amount of energy over here as well. So whatever we do to the reaction here, we have to do to the delta H's over here. All right? So if we switch the reaction, we have to switch the sign of the delta H. If we double the balance, then we have to double the energy. Okay? So those are the kinds of things that we're doing. And then what we would need to do in the end is simply take everything here and we would add it together. Oh, the other thing we did is we divided by 2 this one. We only needed 1 C2H2. We had 2 of them, so we divided this reaction by 2, and we were able to get 1 C2H2. And so we had to divide the energy by 2 as well. Okay, so whatever you do to the reaction to manipulate it so that it matches this one, you need to do to the delta H's as well. And then you add them together to get your final delta H of this overall reaction. Okay? To find the delta H of reaction for this one. Okay? All right. Okay, so I guess this is just going to basically go through that. Okay? So here we need to multiply this by 2. We got 2. So it went from negative 393.5 to negative 797.0 kilojoules per mole. Okay? So we multiplied that by 2. We had to divide this by 2, this in half. Okay? So we had to do that to the energy as well. We're dividing it by half. So here we're going to divide that in half. We're going to get 1,299.4 kilojoules per mole. And now that we have, and we flipped it, okay, we flipped it, so now it's a positive delta H instead of a negative, okay? And so we can add this together, and the overall delta H of this reaction is 226.6 kilojoules per mole, okay? And then we go through, we add that together. So that's the delta H of this reaction. Okay. So for 1 mole of C2H2, 2 moles of carbon graphite and 1 mole of H2, 226.6 kilojoules of heat are absorbed. So this is an endothermic reaction. How did I know it was endothermic from the delta H? Because it's positive. That's exactly why. Okay. A positive delta H is endothermic. A negative delta H is exothermic. Okay. Reaction. Okay, so let's look at a few examples. Okay, so this is the reaction we want to obtain the delta H for this reaction, and we're given this. By the way, this is a really cool reaction, the thermite reaction. It's so exothermic that when the iron gets pulled out, this is actually molten iron. It comes as a liquid comes out, and then it hardens. But it's really hot. Oh, I just gave away that it's exothermic, huh? Okay. Yikes. Come on, pen. Okay, so start with that one. Shouldn't be too difficult. Go ahead, try that. See if I can get my pen to work. I'm sorry? You definitely need to do that. Be right back.
No, I had like no idea what he was talking about yesterday. I was like, I kind of left this one to dry. Like which one? Like which object is it?
It's an experiment.
I get what we're supposed to do. I just don't get like. I'm so glad this is on the test.
Well, later than now.
Just remember, on the final, it's only just a little bitty piece of it.
Yeah, it's probably like one question, but still, you know, like.
That one question could make or break one.
Exactly,
Yeah.
like that's like your error.
She's gonna make it like 10 points. So if you
Yeah.
miss it, you're already at a B. Like,
Fill in the
great.
blank.
So we would have to.
Which equations do you play?
Switch over what I all I do, I do my formula, but I just wait till like
I don't know, it's my preference. I feel like it's more, I would get more use out of it. Because this, I only use Microsoft, PowerPoint, Word, my notepad, you know, if anything has the regular notepad that comes with it, and then I don't use any actual things. I don't use the special keys on it. I don't. It's always use so I don't actually get the full benefit from this.
they're like financial aid stuff.
But then it takes you to the actual financial aid page, you gotta sign up for all that. Yeah. Gives you a checklist.
Now I have to submit my FAFSA.
Yes.
And then I have to like the
Then everything, you gotta read through the terms and conditions for all that kind of stuff. This is what that gives you your little checklist of what you gotta do.
Okay. So what did we need to do here? We just need to flip the bottom one, right? So we're going to take this and we're going to say Fe2O3 solid plus, oops, my eraser's working again too. Imagine that. 2Fe solid. Okay. So we're going to flip that reaction. And then my delta H is now positive 822.2 kilojoules per mole. Okay, so what is the enthalpy of the top reaction?
Negative 847.6.
Okay, so you take negative 1669.8 and add 822.2, and you'll get negative 847.2. Is that what you guys are getting? Just add those together, the top number and the bottom number. Okay? So let's rewrite the equation. That's a good question. They do. 3/4 there, 3/4 there. They're on opposite sides of the arrow, so they will cancel. And you're left with this reaction. That's why they're not showing up there, because they did cancel.
Oh, so you just, okay, that
And
makes
they
sense.
can only cancel if they're on the opposite side?
Yes. If they're on the same size, you add them together. So if you have like 3 oxygens here and 2 oxygens here, you'd have 5 oxygens in your final reaction. But if they're on opposite sides, they cancel. Okay. So if I had 3 oxygens here and 2 oxygens here, then I would cancel 2 here and 2 here, and I'd be left with 1 here, and that would be just 1 in my final reaction. Okay? All right, let me give you another one.
Wait, so why do the O2s cancel?
Why do they cancel? Because they're on opposite sides of the arrow, and they're in the same quantity. 3 halves here, 3 halves here, which is good because I don't have it up here, right? So they should cancel. So I would need to make sure they do cancel because I don't have them in my final reaction. Yes, sir?
So that would be your final answer?
847.6 kilojoules per mole is the final answer. It's the delta H of this reaction.
So would it be over that or not? Or is this the top?
The delta H of this top reaction is negative 847.6 kilojoules per mole. Okay? That's my answer. All right, let's try another one. Oh gosh. Very close together. Okay, and your final reaction needs to be okay. Let me see, pull it down a little. Yeah.
How do you get half oxygen? I know some of them are gonna cancel. That's what I'm saying. I don't know how to get half.
So they're gonna cancel, and you're gonna be left with a half. So you need to don't worry about that yet. Focus on the position of this. Is it in the right position? Okay. Focus on the position of this and the position of that. CH3OH.
So I
Okay.
put the first one.
Okay. So start there. Flip that one, and then look at the amounts of everything. Do I have the right amount of everything?
I multiplied the bottom one by 2, so
Okay.
it gives me 1 oxygen, so the oxygen is cancelled.
So 3 divided by 2 is what?
1.5.
Okay. So if one cancels, you'll be left with.
I'm outside of that.
You have 1.5 oxygens on one side. You have 1 oxygen on the other side. If one oxygen cancels, you'll be left with. Okay. So now make sure you're doing all the math right on the other side too.
Okay, I got it. Wait, I'm still left with 1.5. Because if I multiply the bottom one, it gives me 1 full.
Gives you 2 over 2.
Yeah.
3 over 2 minus 2 over 2 gives you 1 over 2.
Oh yeah, 'cause these don't cancel out. Then, what about the O2 from the graphite equation? 'Cause there's 1.5, there's 2, there's 3 oxygen. O2.
That's 1.5. So that's 2.5. 2.5 minus 1. So 2. Oh, yeah. That's true. Not sure. It's a good point. Not sure what happens that way. That's 1, 2. There must be a typo there, so I'm just gonna put 1.5 there.
I was about to say.
Where was that? Where did you change?
They must have a typo there somewhere. We're gonna put 1.5, 02.
Okay.
So that doesn't really change much, right? I would still have to leave it the same, right?
Leave what the same?
Like everything I did because
Yeah, you were doing everything right.
yeah, okay.
Yes. Yeah.
I'm just stuck on which to do
After you flip H2, or which one?
I flipped the top one. The C.
I mean, yeah, that's the top one. Okay. So you flipped it. And what did you do to the delta H?
Change the sign.
Okay, good. So you change the sign after you flip it. Do you need to increase the balance at all? We can keep it the same, right? Because we just need one CH3. So we don't have to do anything else. So we just change the sign to a positive, and that's all. And so we flip this, so that's it. Right? And then we change the sign. And then for the other two, you can leave them here. You don't have to flip them, right? But this one doesn't have the correct number of hydrogens, right? So what do I need to do to this reaction? You need to double it. So this has to become 2. This becomes 1 and 2. Okay? So my Okay. Sorry guys, I didn't put this in here correctly. That's it too. Okay. So I didn't put that there. So these will cancel because they'd be on opposite sides. The waters would be on opposite sides if I flip that. Okay.
Oh, okay.
So that would cancel. Okay. And then we'd have to also multiply this by 2. Okay.
Did you just write that 2 in, or was that?
It was supposed to be there. I forgot.
It was
I didn't write
okay.
it originally. I missed this when I was writing it instead of reactions. So, but that does cancel those waters. So they're not in the final reaction. And then we will multiply the bottom number by 2. Okay. And then that's going to give us this bottom reaction that we need. Okay. And then you add everything together. What do you get? What are you guys getting?
Still not sure. How are you getting the 1.5 oxygen on the bottom?
Okay, so if I flip, let me go ahead and flip this so we can see how this should be.
Oh, the one there. Yeah, okay, I got it.
You okay?
Yeah.
So I have 1.5 there, and I have 2 here.
Here, yeah, they cancel. Or, I mean, yeah, it's like.
1.5.
Is that it? The other one all not cancel out. Can I just put half as possible?
Oh, I do have a half.
Yeah.
Yeah. You guys are blowing my mind. Yeah, that is a half. So it's not a typo.
Yeah.
So, yeah, I was just doing the math wrong. So 1.5, because this thing gets over here as 1.5. This is 2. 1.5 minus 2. There we go. That's the half.
I don't understand.
Yeah, we're okay there.
So wait, so how do you end up with the half?
Okay, so I'm going to rewrite this equation because I think this is the thing that's really getting us in a mix up. Okay. So that's going to be carbon dioxide gas plus 2H2O liquid is going to produce CH3OH liquid. And I'm going to write it as, instead of a fraction, I like to write them as decimals, because that will really help us better see what's happening. Okay? So, okay. So on this side of the reaction, I have 1.5 oxygens. Over here, I have 2 oxygens. So when those cancel, I'm going to cancel 1.5, and I'm left with just a half. Because I had 2 over here. 2 minus 1.5, you're left with what? 0.5. Okay, so I have 1.5 here. I had 2 over here, right? So these 2 minus that 1.5 will be left with a half.
Oh,
Okay?
I see what you're saying.
You okay?
Yeah.
Okay. Okay, so what are we finding the delta H of this to be then? So we change this to a positive. So 726.4 minus 393.5 minus 285.8 times 2. Yes. So that's why we made it a positive here. What are you getting? Kilojoules per mole. Okay, that's what we get. Yes.
Can you take me step by step on how you did this? Because I feel like we're all over the place.
Okay, so let's start right here at the top one, okay? So this reaction was written the other way, correct? Okay? And I flipped it, and then I got this. I changed the sign. Okay, you're okay with that one? Okay. Look at the second equation. I need graphite. Okay? Here I have graphite, and I just have one of them. So I don't need to do anything to this. It's in the right place, and it's the right number, amount. So I leave this one completely alone. I don't have to do anything to it. Okay? Then I look at this equation. This is how I started it out. Okay? So I had 1 hydrogen. I look at my final reaction and I need 2. So what do I have to do to this? I have to multiply everything by 2. So this becomes 1. This becomes 2. Okay? So that means I have to multiply my delta H by 2 as well, because I multiplied this by 2. Okay? Then I look at now, what is everything matching here? So water. Is water in this reaction? No. So that's because it cancels. It's on opposite sides of the arrow. Okay? I have 2 waters over here, and I have 2 over here. So they cancel. Okay? Look at my oxygens. I have 1.5 oxygens over here. I have 2 oxygens over here. So 1.5 oxygens are going to cancel on both sides. So I'm left with half of an oxygen, okay, over here. Okay? And so then to find this delta H of this final reaction, I just add everything together, because I manipulated these to be the same as I did over here. So I flipped this one, and I multiplied this one by 2. That's all I had to do. So I went ahead, and I add these all together, and they will give me this. Okay? Okay.
So, like, before how you had it, like, it was on the opposite side, we could just rotate it around and it's cool, but you have to put it to positive, right?
You have to change that to a positive if you flip it. If it's a negative, if it's a positive and you flip it, you change it to a negative. Okay? So whatever you do to the reaction, you have to do to the delta H as well. So if I flip the reaction, I have to flip the sign on the delta H. If I multiply the reaction by 2, I have to multiply the delta H by 2. Yeah?
Can you show the whole thing? You have it to the side.
Oh, I'm sorry.
Thank you. So I guess
Up? Down? That's everything, right?
so your original top was a 2H2O.
Was originally 2H2O. Yeah. I had first written it down incorrectly with only 1. And then I put the 2 there.
Okay.
Because I had done it incorrect.
I wrote it down the same way.
Actually, that's a good point. I mean, if something's not working, check to make sure you wrote it down correctly, because that happens to me a lot of times. Like, wait, something's not working out. Oh, it's because I forgot something. Okay? Because a lot of times it's it should work out pretty well, right. So if you're like, hey, something's not working out here. Okay, any other questions about this? I'm going to do one more of these, okay? Some of you are probably now like, oh, this is getting boring, Mr. Crandall. This is easy stuff. Okay. No? Nobody's feeling like that?
It's just one of those things.
Okay, so go ahead and write this down, and then I'll move it over for the delta H's. There we go. Let's make it smaller.
So for the final, are we gonna have where it's gonna be 2, or are we gonna have 3?
You could have potentially both.
Will it be any more than 3?
I don't think there'll be more than 3. You don't usually see more than 3. You potentially could, but I don't think you will.
What is the date of the final?
Your final is Monday of finals week. It's the very first day of finals week. Not this coming Monday. A week from Monday. So you're gonna have your exams, and then it's the Monday of finals week, whatever day that is. Because you're the 8 a.m. class, so you get the first final. Yep, you'll never have to see me ever again. See you later, Mr. Crandall. Yeah. Except for all those emails I'm gonna get. Yeah. you're going to have to divide it. But what you're going to focus on is how do I make this match this? So before you're canceling, just make sure you have the right numbers of everything here as you do here. Do that first, and then look at what cancels.
Do you
Okay?
always have to flip an
No,
equation?
not always.
Not always.
Not always. Sometimes it's just everything set up perfectly, and you just add them together.
Okay, so I was like, I don't see anything.
You are going to have to flip something here.
Yeah.
Uh-huh. But that's a good, you don't always have to, but you do have to here. Because look at this.
Yeah.
This is a reactant, but in that top reaction, it's a product.
Yeah, that's what I'm doing, but I don't know.
So you're going to have to flip it. Top one, because you want this over here. So it needs to be on this side. It needs to be a...
So BRF are like on the second equation.
Yeah, you're trying to make these match this one.
Okay. Yeah, I definitely. Yeah. Here we go. 3 divided by and then here is use cancellary.
Yes. That's right.
Yeah. Right. 5 by 1/2. Right.
Yes. On the top one should be BRF. No, it's BRF. Yeah, this BRF is going to react with F2 to become BRF3. Okay. So that's how the reaction follows.
No, they will be. Because one divided by two.
Okay, does somebody think they have it?
Yes.
Should we like wait?
Okay, what are you guys finding?
Flip the top one, divide by 2, and then just divide the bottom one by 2.
Okay, and you get what? What's your delta H?
Negative 290.
Okay.
Wait, so after you divide by 2, you did what?
Okay, so that's right. So if you're getting that, you did it right. Okay, so let's look at how we get there. Okay, So first thing I want to do is I want to flip this top reaction. So I'm going to go ahead and flip it. So we're going to get 2BRF produces Br2 liquid plus F2 gas. Okay? And then I change the sign here from a positive to negative to a positive. Okay? So that's my first step. Now look at the number of BRFs down here. I only have one, right? I have 2 up here, so what do I have to do to this? Good, I have to divide it by 2, right? So I'm going to get this as 1. This is going to be 1/2 Br2, and this is going to be 1/2 F2, right? And then I'm going to divide that by 2. Okay? We're okay so far? All right. Now look at how many BRF3s I have here. I only have 1. I have 2 here, so what do I have to do to this reaction? I have to divide it by 2 as well. So I'm going to get 1/2 Br2. And then instead of, I'm going to change these to decimals. 0.5, 1.5, okay, and 1. Okay, so that means I need to divide this by 2 as well. So now let's look at the Br2s are going to cancel. 1/2 here, 1/2 here. So those cancel. They're on opposite sides of the arrow. They're the same amount, so they cancel. F2, I have 0.5 F2s here. I have 1.5 here. That leaves me with how many? 1. So 1, that cancels there, and I'm left with 1 F2, and I get 1 F2 down here. BRF3 as well. Okay? So 188 divided by 2 minus 768 divided by 2 will give me negative 290 kilojoules per mole. Okay?
So, why don't those cancel out?
Say it again. What?
Cancel out.
Why don't they? This is BRF and this is BRF3.
Oh.
Yeah. So this is what we're making. From BRF, we're reacting it with F2 to make BRF3. That's right.
So,
Yes.
so why did the 0.5 cancel out?
Say it louder, I'm sorry.
The 0.5 F2?
Why did it?
Why did it?
Okay, because I had 1.5 here. Okay, and they're on opposite sides of the arrow. So I have 0.5 here, 1.5 here, so 0.5 is going to cancel. So I'm left with 1. Okay?
So technically you subtract, like, whatever, they're opposite, you subtract.
That's right. If they're on the same side, you add them. If they're on opposite sides, you subtract them. Okay? All right, we're okay with that? Good. Okay, let me give you a different kind. Whoa, too big. Okay. Okay, so C2H4 plus 3O2 gas. This is gas. Produces 2CO2 gas. plus 2H2O liquid. Okay. So this one we're going to do using the delta H's of formation. So this is our reaction. Okay. And if we go to the back of the book, okay, the back of our textbook, there would be a table in the back of our book that would give us the delta H's of formation for these, okay? And we'd be able to then, so what do we say is appendix G, okay? Put those numbers in here. So the delta H of formation for C2H4. So C2H4 gas, right? Delta H is 52.4. 52.4 kilojoules per mole. What's the delta H of formation for O2? Who can tell me? You don't need a chart for that one. What's the delta H of formation? 0, right? Delta H of formation for O2 is 0 because it's all by itself in its elemental form, so it's 0. Okay, delta H of carbon dioxide. Let's see, carbon dioxide has a delta H of formation of, that's gas, right? Negative 393.51 kilojoules per mole. Okay, and then the delta H of formation for H2O. Gas or liquid? Liquid. Negative 285.83 kilojoules per. Right? So we just found all that data in the back of the book. That's where it is. Okay? Or if you're given a question like this on the test, it'll be in the question. They'll say these are the delta H's of formation. Okay? So you would solve for it using those. Okay, so the delta H is equal to products minus reactants. Okay? So that's how I'm going to find my delta H. So I'm going to need to find the sum of the products, and then I find the sum of the reactants, and I subtract them from one another. Okay? So first here, I'm going to have to take this 393.51. That's per mole, right? Well, I have 2 moles, so I need to multiply this by 2. Same thing with the water. Okay? That needs to be times 2 as well. This can stay as it is because it's all by itself. Okay, there's only one of them, so I don't have to change that. This I don't need to multiply by 3. It's 0, so 0 times 3 is 0, right? So I can leave that alone. And then, so basically, whatever this number comes out to be after you add these two numbers together, after you multiply each one by 2, you add them together, you subtract 52.4 from it, and that'll be the delta H of this reaction. Okay? Okay, so go ahead, do that for that one. What is our delta H?
Negative 1,125.23.
1,125. Okay, so I need that verified. See, it's not quite what. Is that what you guys are getting? No, what are you getting? Yeah, that's more. Negative 1,411 kilojoules per mole. Yeah. Okay. Just take that off. Okay, that's what you should be getting. Okay, so that is the right answer. So if you're doing this correctly, that's what you'll be getting.
So the only thing you did was multiply negative 393.5
Times 2. And then I added 2 into 285. Or multiplied. Then I added it to 2 times 285.83.
You added a 2, okay. So you put a 2 in front of the 2H2? Because there wasn't a 2 before.
Yeah, there was.
There was?
Yeah. I did not add anything. That was there. This 2H2?
Yeah.
Oh, yeah, I had that there. That's been there. That's how those guys got it.
Yes.
Okay, those are the delta H formations for this, the compounds in this reaction here. Okay, so determine the delta H of this reaction. And these are all in kilojoules per mole. $60.9.
Negative 1,243.
There you go. You got it. Make sure you're multiplying by the coefficients. You're adding, so you're multiplying this by 2. You're multiplying this by 2. You're adding those together for this side. And then you're going to subtract 20.15 times 2 from it. So products minus reactants. 1,100.
Oh,
1,100.
Yeah, negative 1,143.
That's right. That's right. Okay, negative 1,143. Is that what you?
Or you know what that might be?
That's right. 1,400.
I didn't multiply the negative 20.15 times 2. That's what I get without.
Oh, it's 24. It's 24.
Okay.
Negative 1,143.
Yeah, 24.
That's what it is. Yeah. Yeah. Okay. So this is what you should be getting. Okay. So we'll see you guys on Monday for your test, and then we will review Wednesday. So congratulations being here on the day before Thanksgiving. You guys did it. Okay, if you miss roll call, let me know.
You're gonna have the key up for the 7.
Today. Later today. You do?
Brighter, it has a better battery, it has a better pen, and it might be featured on like good residual screening, and it's very nice on the road. Several pros better. I have more like the solid plate.
But I guess that's probably a big day.
Like we have kind of every day.
I got you, Deanna. Oh, and then on that home the problem. So the problem I'm running into is that I'm gonna post a key feed because they're gonna study it for the test. So I can't really accept it. So I think we'd have to figure something out.
Okay. Okay. That's fine. Thank you.
Hello? Hi. Yeah. Okay. Well, I'm starting class at 9:30 also. But I can roll up, maybe I can ask Erica or somebody to sit in there. Okay, is it 3:44? Yeah, yeah. Yep. Yes. Yes. Absolutely. Okay. Let me go. Yeah. Okay. Yeah. Yeah. Of course. Of course. Okay. Fine. You guys, I'll be right back. I have to go talk to somebody really quick.
Yeah, because this, let's do it again. I'm gonna do it again right now. So 2 times negative 285.8 is negative 571, right? 6 plus 2 times negative 1 be negative 5 2. So these just add together since this will be negative, right?
Yeah.
So 5 7 1 plus 5 9 2 is negative 1 1 6 3.8, right? So then this one is 2 times negative 20.15. It's negative 40. So just add these together.
Yeah, so it's going to be whatever this is, the sum of this minus that.
So this minus that. So 163.8 plus 40.3 is negative 102.
Oh, look, it does equal that.
It does?
So you're not doing the negative.
Doesn't is a negative?
Yeah, so you're doing negative 160.8 minus negative 40.3, which makes it a positive. See what I'm saying? Plus 40.3.
So it's this
Minus
minus
negative. And can you see how that would equal a plus?
yeah.
Yep, there you go.
Okay, never mind.
You're good.
We solved it all.
Oh my goodness. Yeah, yeah. Usually I have a lot of issues trying to sleep, but there was
Yeah.
So
If there's not enough things out here to stay, imagine at 7 o'clock.
yeah.
I was like, I mean, I usually get good parking, but it's like even better parking.
Yeah, today. I guess have like a break, yeah. Gosh, yeah, I have a 2-hour break between my night class too, just cause like Sunday class is like, it was like, so, I usually just like do commercials, but, Monday, my teacher decided to pass my class and just let's go to the door, so I waited here for 2 hours after this class, went to my class, and I'm like, oh, kind of left 2 hours. Thank you.
Did you get homework done?
Yeah, but it's so annoying. Like, it's not like you don't have like teachers don't have like a way to as much. It takes less time to put that thing on the door. I mean, less time to send a message and put the thing on the door. Like, it's not that hard.
Yeah.
Just been nuts.
Those are usually the ones that.
Yeah, she was like, and then she was like, check canvas. She can't be nothing. I'm like, check canvas. Exactly. So I'm gonna go after this class to see if it's canceled again today. 'Cause, you know, I feel like she's probably just like trying to take off like the Thanksgiving week and just didn't want to tell us. So. I don't know, but I have like 4 minutes away to test breath. It takes me like off like 4:30 rows to like yeah 21 and kind of yeah. So whatever. The only reason I put me here at all is because this one class.
Okay, good. My computer's still here. It's probably still recording from last class.